This question comes from the 1988 AP Calculus BC multiple choice portion, number 43. Now, you might be wondering, why are we doing a BC problem in AB? Well, BC covers AB. And so many, not all, of course, but many of the problems will be something that you will want to take a look at as an AB student. So here, a bacteria in a certain culture increases at a rate proportional to the number present, so the number of bacteria. Now, that's important when you read this problem. So we've got a rate of increase that's proportional to the actual number that are there. So here we know that dy dt is going to be equal to k times y. Now, that also means if we solve this differential equation, it's going to look like this, where y is equal to a, some constant, that's the beginning amount, times e to the k t power, where k is that constant that was in the differential equation. And here it says if the number of bacteria doubles in 3 hours, so that's going to be some important information. And then here's the question: how many hours will the number of bacteria triple? So that's what we're asked to find. Let's use that given information, the number of bacteria doubles in 3 hours, to help us. Maybe we'll be able to find how many hours the bacteria will take to triple. So if we think about this, the y is the ending value, and we want the beginning value to double. So the ending amount is going to be 2a, and that's going to be equal to a times e to the kt power. Now, if we divide by a on each side, the a's will be gone. We'll be left with 2 is equal to e to the k, and then I forgot to actually substitute the t, and we do know what the t is for this one. So the t is 3 hours. So that'll be e to the 3k. And then we're going to change this into a logarithm. So this will be the natural log of 2 is equal to 3k. So k in this case happens to be the natural log of 2 over 3. Now that's just the value of k, so that doesn't give us the number of hours. That's going to be t, that the bacteria will triple. However, that's going to really help us because it allows us to figure out one of those variables that we didn't know before. So that k value is the natural log of 2 over 3, and then the times t is up here. Now, to answer the question, we want to know how many hours will the number of bacteria triple. So y in this case will be 3a, right? That's triple the beginning amount. And we're going to solve this one for t. Luckily, the a's will cancel here if we divide by a on each side. So we have 3 is equal to e to the natural log of 2 over 3t. And we can change this into a natural log. So we've got the base being e, there's your natural log of 3 is equal to the natural log of 2 divided by 3 times t. The next thing we're going to do is multiply by the reciprocal on each side of that natural log of 2 over 3. So that's 3 over the natural log of 2. And the natural log of 2 will cancel, and the 3 will cancel, leaving us with t being 3 times the natural log of 3 over 2, which is choice A.